That was the third movement, entitled Of Leibniz and Bach's Well-Tempered Clavier, from my third symphony, Hermeneutic Renewal. I'll play another passage at the end of the episode. You can download the entire symphony and explanatory notes from my website if you wish. I've come to see Johann Sebastian Bach in person, right across the square from the Musikhochschule. He lived here in Weimar for more than 10 years, early in the 18th century, employed as music director at the ducal court. He wrote material for his first Brandenburg concerto here, and many cantatas and other pieces too. Weimar is a town of heritage and museums, but unfortunately there's no Bach museum, in part because all that's left of the house where he lived just over there is a wall. Behind the wall is a parking lot of the Elephant Hotel. Nevertheless, it's still a very interesting wall. There's a large Bach festival held every year all across Thuringia, but other than this and other than the bust, it's this wall that represents the physical presence of Bach in the town, and that makes it an important wall. The plaque says Carl Philipp Emanuel was born to the Bach family here, he of the Sturm und Drang movement that also inspired the young Goethe. If it's problematic to express musical matters in any terms other than musical ones, such as in terms of cognitive language, then it's even harder to express such things by way of a wall. If I want to talk about Bach's debt to the hymn tunes of Martin Luther, or if I want to refer to Bach's remarkable use of harmony modulations, or his use of contrapuntal line with several fairly independent melodies being sounded together, then none of these things, especially those musical lines, seem on the surface to be analogous with the rigid straightness of a wall. Nevertheless, given Weimar's associations with German idealism, a wall should never be considered as merely a wall. Indeed, its geometrical shape can be seen to have great meaning. If I stand here, I have a particular perspective of the wall. And if I stand here, I have another. But always I perceive the wall as fixed and unmoving. I perceive myself as moving around it in a landscape of fixed physical dimensions. The wall represents a flat plane wherever I stand. After all, straight lines are straight. Bricks and walls and buildings comprise many right angles, and triangles comprise interior angles that are the equivalent of 2 right angles. These are the axioms of geometry defined by Euclid during the era of ancient Greece and held as universal descriptions of reality for more than 2,000 years until subject to the principles of idealism and in particular the epistemological constraints of Kant's transcendental idealism. In his Critique of Pure Reason, Kant rejected entirely the models of space and time proposed by his predecessors, including those of both Newton and Leibniz, whereby physical space has an objective reality independent of the subject. He argued that space and time do not exist as objective entities, as things in themselves. Instead, they're the relationships that exist between things as perceived by the subjective observer. He isn't rejecting the idea of physical objects existing in space. He insisted it's not possible to know the truth of this due to the constraints of cognition, but he insisted that knowledge of geometry and the structure of the physical world are determined by the faculty of cognition. They're mental constructs developed by the mind. The supposed reality of a straight line, or of a nice straight wall like this, or alternatively of a nice curved contrapuntal line, is entirely subjective. Yes, straight walls are not straight walls in Weimar. This was a challenge placed on Goethe, Schiller, Herder and all of the Weimar classicists. It's also a challenge placed upon those of us who strive to be neoclassicists and neo-idealists and neoclassical anti-realists today. How can we reconcile line and pattern, the objective and the subjective, the laws of nature and our experience of the world? How can this wall inform us how to write an opera that expresses our place in the world? These questions could be taken in many directions, but given it's Bach's wall that started this, and specifically its straightness in contrast to the non-straightness, the aesthetically profound curvatures of his contrapuntal lines, I want to look briefly at how these ideas have contributed to thinking in mathematics and logic and science. I want to consider the principles of conventionalism. This will help my further discussion in later episodes as regards scientific realism and how it pertains to anti-realist objections to theories such as anomalous monism and eliminative materialism. Actually, it wasn't the eventual development of non-Euclidean geometries during the 19th century that caused the view of conventionalism, the subjectivity of theory, to be taken seriously. If I draw a large triangle on the surface of the globe, or a smaller triangle on the model of the globe at home, then it's no longer on a two-dimensional plane and its angles are different. If I put one corner on the North Pole and draw a line down one of the longitude lines to the equator, and then draw along the equator for the equivalent of 90 degrees of longitude, then connect back to the North Pole, whereby all lines are now perpendicular, then the interior angles will now add to 270 degrees, not 180. The work of mathematicians on this and other related issues continued into the 20th century. Gottlob Frege, who taught at the University of Vienna, was very influential in the field of theoretical mathematics. However, he moved out of geometry and into the interconnectedness of arithmetic and logic, so I'll look at his work in a future episode. As an alternative, given I'm devoted to decoding the Bach wall, I'd like to consider the work of Henri Poincaré, who taught at the Sorbonne in Paris, and who continued to explore the fundamentals of physical structure as it pertains to walls throughout his life. I'm sure he must have taken vacations in Weimar and stood on this very spot, given his achievement. But anyway, in addition to his work in physics and electromagnetism and the principles of relative time and motion, he also looked at the epistemological justification for an axiomatic for geometry. Heinzmann and Stump said, Poincaré argues that metric geometry is neither a priori nor empirical, but rather conventional. The worldwide community of mathematicians and scientists chooses a particular set of axioms above any other, not because it represents some universal truth about geometrical fundamentals, but merely for reasons of practical convenience. The choice is contingent and entirely arbitrary, and constrained only by the pragmatic necessity for circumventing inconsistency. There's a pedestrian with a dog walking past. The wall is in a fixed position grounded to the earth, and the pedestrian is walking away from it. Either that, or he's in a fixed position grounded to his personal subjective perspective, and the wall is moving away from him. I have no doubt he perceives the former, as I do, according to convention. I perceive light travelling in a straight line, and billiard balls doing the same, and walls made of straight lines, and consequently, intuitively, without really thinking about it, I assume the straight line as a fundamental axiom of physical spaces. Everything in the world conforms to Euclidean geometry. And when I see light bending, because I've got particularly good eyesight, or a particularly impressive experimental setup back in the physics lab at school to help me see this, then I think to myself it's because the light really is bending. The world remains fixed in Euclidean space, and the light is bending within that space. Or similarly, I'm sitting in the concert hall listening to Bach, and the music is a beautiful patterning of sound within that fixed space. However, if I was to insist counterintuitively that light always travels in a straight line, because that's supposedly the physical nature of light, and it's travelling in a straight line even when it appears to me to be bent, then this would mean that the entirety of space would be non-Euclidean. Kant wouldn't have liked this approach, but Einstein did. I'm sure Einstein would have liked this wall too. It could be that he visited here when he developed his general theory of relativity, which explores how time-space is something that can be acted upon by mass energy and become curved. Here's another example. The Earth goes around the Sun in a circle, roughly a circle. It doesn't travel in a straight line because it's in orbit around the Sun and the gravity of the Sun attracts it and causes it to follow a circle, yes? But actually, again, this assumes space is fixed and the Earth is moving in this fixed space according to the laws of gravity. However, if I insist counterintuitively that the Earth can only move in a straight line, after all it's only a lump of rock with a semblance of kinetic energy, and of course one or two very nice walls, then it's space that is not fixed. Space is curved, and accordingly the beautiful patterning attributable to Bach of sound in the concert hall is not what I intuitively thought it was. Heinzmann and Stump said of Poincaré, apparent hypotheses are definitions or conventions rather than actual claims about the world. Indeed, in response to Einstein, Poincaré argued that scientists would now choose between special relativity and Newtonian space-time entirely on grounds of convenience. It would not be an empirical decision at all, as both theories could be shown to fit the available evidence. Actually, he was making this point because he wanted to argue that all knowledge, and even seemingly rock-solid mathematics, is relative and not absolute. There is no privileged epistemic ground for Euclidean geometry, even if it's uniquely tied to human spatial intuition. Descriptions of the world will always be influenced by factors beyond the theory applied to the evidence. Straight lines and triangles with 180 degrees are intuitive to a human spatial intuition of a flat plane world, but they do not necessarily denote a one and only reality. Heinzmann and Stump continued, Poincaré argues that what science can attain is not the things themselves, as a naive dogmatists think, but only the relations between things. Outside of these relations, there is no knowable reality. Poincaré's theory of conventionalism remains important today. It asks how, in circumstances where the total sum of all scientific evidence can be shown to support two different theories, a community of thinkers is able to choose one theory above another. Conventionalism says a choice is a matter of convention, and that alternative conventions are equally valid. I would like to apply all of this to Bach's contrapuntalism, and to the notion of line and pattern in music, and to the prospects of writing an opera. But before doing so, I should add that conventionalism is interpreted in two different ways today. For the sake of simplicity, I'll characterize them as hard and soft versions. Soft conventionalists argue that the influence of convention in developing knowledge is merely a consequence of the limitations of available data and of the underdetermination of evidence. If the available evidence can be shown to support two different theories, then eventually, after further experimentation and the collecting of more evidence, it'll eventually be possible to choose one model above another, or to jettison both in favour of something new. In other words, conventionalism is irrelevant, a trivial facet of a community's gradual development of shared knowledge. Willard Quine, working at Harvard University during the second half of the 20th century, whose entire approach to naturalism relegated epistemology to psychology, was an exponent of this view. He wrote, "What the empirical underdetermination of global science shows is that there are various defensible ways of conceiving the world." He conceded that, given scientific knowledge was an interrelated web of belief, it would never be possible to separate fact from convention. He acknowledged that all knowledge is bias, and it's not possible to separate the bias from the knowledge. It's not possible to separate scientific fact from the social circumstances producing the scientific fact. The principles underpinning theory are built upon agreements in society, as well as on external reality. However, he added that conventions are always under pressure from empiricism, and consequently their long-term impact is to be considered minimal. In contrast, hard conventionalists argue the points I made earlier in an uncompromising fashion. In the same way that units of measurement, centigrade or Fahrenheit, centimetres or inches, are used by convention to enable descriptions of the world, so hard conventionalism says theoretical descriptions are also matters of conventional choice. Following on from the work of Poincaré, this approach posits that there are no fundamental laws concerning the geometry of physical space, and consequently, geometric axioms cannot be evaluated as objectively real, as true or false. If I apply these two approaches to music, I think I can easily apply the principles of soft conventionalism to matters of interpretation. Clearly, performances of Bach are determined by convention. Musicians look to various sources, including their peers, for ideas concerning performance practices. Even audience experience of Bach is governed by many customs that are developed in parallel with broader social norms, such as the context created by the juxtaposition of serious music with the muzak pipe to society in supermarkets to make people jolly, or at least less grumpy, and buy more products. In contrast, the principles of hard conventionalism are far more radical. They challenge the very notion of the phenomenal experience of music and the metaphysical implications. Just as with the wall, when I listen to Bach, I perceive myself as a fixed and unmoving entity, and the musical line moving around me. It's the exquisite patterns of this movement, sometimes decorous and sometimes surprising, that preoccupy me, but my aesthetic judgments take for granted many issues about the nature of that experience. I assume that the forward movement of time is fixed, and that the music is moving in relation to that time and not the other way around. Indeed, I find it counterintuitive and even absurd to think that music might be fixed and that time or phenomenal experience might be moving in relation to the music. I assume that the moving lines and patterns I hear in the music, the melodies, harmonies, timbres, exist within the context of a fixed sound world, which can be determined either qualitatively or quantitatively, such that a rise in pitch whereby the frequency is increased, or such that an increase in volume whereby the amplitude is increased, is relative to a fixed physical world of sound waves and aural sensibility. It's counterintuitive to think that the change in pitch as a phenomenal experience is itself the point of perspective, and that the physical world is relative to this. I ask these questions about something as banal as a wall, even the Weimar Bach wall, because the very nature of human thought is to assume many things by convention without ever really thinking about it. I'll look at what Nietzsche had to say about these matters in a later episode, but for now it's enough to recognise that intuitively we develop a kind of folk psychology that satisfies us with its explanations without realising what it is we're taking for granted. If I'm going to answer the questions underpinning my inquiry, including matters pertaining to music, children's learning, and the meaning of Weimar classicism to the modern world, then my inquiry will need to test some of these assumptions. In the meantime, here's another section from my Third Symphony and the third movement of Leibniz and Bach's Well-Tempered Clavier. Thanks for listening.